Hello guys, on this episode of Up to Spec with Seth, we're going to be talking a little bit in depth on this idea of gain and how it closely correlates with the three levels of noise that you'll come across in your recordings. Now, just get this. It's not going to be too complex that you're not going to be able to grasp the idea, but they are going to be building off of the basic ideas that I have shared in previous episodes. Now, we're going to be starting off with the microphone part and how microphones have their own gain. Now, right over here, this is a handheld dynamic microphone, the Behringer XM8500, and also right here on my left is the Shure SM7B. It's a broadcast dynamic microphone that is commonplace in our radio station at CGSW. Now, I always like saying that because it's good to know your equipment and what you have there, right? So, broadcast dynamic microphones and handheld dynamic microphones, what are the differences? Is there any difference? They're both dynamic microphones, so they both must have the same strengths and weaknesses. They're good at bass, they're good at mid-range, but they can't really capture the highs. And also at the same time, they're kind of harder to drive. But what's interesting is that we're going to be talking about their context. Context. They really play a role in how a microphone is designed and also what it's designed to capture. But at the same time, it can also help determine whether or not you need a lot of power for it or you don't even need to worry about the power because you can just plug it into your computer and it'll work just fine. For handheld dynamic microphones, these microphones in context are designed for live performance, to be used at a venue, to be used on stage, to be used in open mics. You'll even see these because of the way that they were designed, commonplace in bedroom production. These microphones are super duper versatile. You can throw them on top of any kind of instrumental to record. You can throw them in front of a guitar amp, on top of acoustic guitars. You can also see these on drum sets. These things are versatile. Whether or not it was the Shure SM57 or the Shure SM58, you're going to typically see a handheld dynamic microphone used for not only vocals or for voiceover, but also for instrumental recording. But these microphones are not going to be the most detailed. They only cover such a very narrow range of the frequency response. They can only get 50 hertz up to 15,000 hertz, and it's not like they're not high fidelity or they're not good built. It's just that engineers thought that wasn't important. The information that is above those ranges. You have over here the weird fancy going on air frequencies above 15,000, and then you have the sub bass. It's the bass that you feel when you're listening on speakers or on your headphones below 50 hertz. Now, because of those being canceled out, it actually gives these a lot more ability to capture and to really hold on to the voice. There's going to be a lot of stuff and details that you don't really need during a live performance, and this is going to be able to cut those out. And not only that, these are easy to drive. These can be brought to any venue, whether or not it can be someone's home studio or one of the biggest venues that you can come to with like powerful amplifiers and all that jazz. This is typically going to be easier to drive than a broadcast dynamic. And it's all down to that these are going to be carried with you as an artist or they're going to be held on stage as an artist. So you can bring these wherever you want. They're easy and portable, small and tiny, easy to drive, beautiful, but they're not going to capture a lot of those details and intricacies of the voice. Unlike dynamic broadcasting microphones. These dynamic broadcasting microphones are going to be able to cover a majority of the frequency response. It's going to go from 20 hertz to 20,000 hertz, just like the Shure SM7B, and that typically means we're going to get all those fancy air frequencies that you may or may not even recognize, or that little punchy sub bass below 50 hertz. That's kind of good. That's kind of good when you're doing recordings, and especially as a music engineer or as any kind of sound engineer. It's nice to have all those frequencies at your disposal when you're doing editing or making the final product. So, cool. More fidelity, more things it can capture, but what else? Well, their size. These things have a lot of engineering into them compared to handheld dynamics. Handheld dynamics just need to be designed to handle well in your hand, but broadcast dynamics are all about the acoustics. Of course, I've mentioned this before, the Shure SM7B is designed to also be used with the windscreen that offers it its sound. But typically, most dynamic broadcasting microphones, such as the Shure SM7B or the Electro Voice RE20, will also come with these dials at the back of the microphone, which is typically at the studio protected by a little plate. And if you unscrew it, you'll see these two filters. There's going to be one filter that's going to actually roll off the low end, which will remove a little bit of the bass, but it's going to improve handling noise, which is just like when you're tapping the boom arm or your microphone. It's not going to be as noticeable in a recording if it accidentally happens. And especially on the radio, that's going to be very useful for us if we're really moving the mic arm all the time and we don't mute. But also on top of that, these also have typically a brightness boost. You can actually see a little hump up here in terms of like what that symbol looks like when it's switched on. On the Electro Voice RE27, not the RE20. There's actually two additional switches that take care of not only the bass roll-off, but also the mid-range and the high range that can make the microphone a little bit more bright. And because of this, a dark microphone, especially a dark microphone like the Shure SM7B, which is again a dynamic microphone, which naturally it is darker and bassier, you can add a little bit of fun brightness to it. And that's actually something that most handheld dynamics don't have, is that adjustability. These are just supposed to be used for live performance. We don't care about those details. But even something as simple and also as niche as a role of broadcast dynamic microphones, which are designed specifically for the voice, they have that adjustability. They're supposed to cover basically every single range that a human voice could possibly be speaking in. So cool, these things are versatile in terms of the voice, but can they be used for instrumental recordings? Yeah, depending on who you ask. The RE20 was always thrown in front of a bass drum, and the Shure SM7B you would actually sometimes see on a snare drum or on the bass drum in front of a guitar. These things are also versatile, but typically, in terms of their context and design, they were not meant to be used for travel. You wouldn't see these in a suitcase unless you were very crazy and you wanted to bring your own with you so that, you don't talk into the same microphone 500 other people have. But, no judgment. These things typically are going to stay in the studio. They're going to stay in the booth. They're not going to move around like a handheld dynamic. Now that we've covered both of these, they're both dynamic microphones, but they have different contexts. But there's something I didn't mention yet. Broadcast dynamic microphones typically are going to require a little bit more power. They're going to be assuming that the booth that you're in or the studio that you're going to put these microphones in as your standard is going to have enough power to drive them. Unlike these handheld dynamic microphones that are typically made for any kind of scenario, whether again it's going to be an $80 interface at home or something very big at a venue. These microphones are easy to drive, versatile, and will typically just get what you want, which is the voice, especially when you're singing. But broadcast dynamics are going to be harder to drive. They're going to be used specifically in-house or, again, in one location. They're not going to be really brought around all the time, and they have a major focus on voiceover. So cool. Broadcast dynamics, handheld dynamics. What do they sound like? We're not really caring about the sound so much, but as the power, which again is the part of this video. Gain. So as you can see right here, we are hitting the levels that we ultimately want. I'm a little bit excited today, so I had to draw back the dial a little bit. So we're very shy off of 3 o'clock right now on that gain level dial. So what we're going to do is we're going to switch over to the Electro Voice RE20, and we're going to see how much more quieter this microphone is compared to this handheld dynamic offering from Behringer. So as you can hear now, I'm going to be at the same distance and the same loudness that I was before, but as you can see, we are only peaking at -18. We're not really hitting the same numbers or the same range as we were with a handheld dynamic. It actually sounds a little quiet. And again, that's by design. It's going to be assuming, okay? These companies are assuming that you have the studio equipment to be able to drive these things. Because just like headphones, the more expensive they are, it typically means that you have a beefy amplifier to power them. So let's give this more power. We're just going to be talking at our normal speaking level, and we're going to move this just 2 notches up, maybe just an extra 2, and it looks like we're hitting the levels that I would deem necessarily comfortable for the distance and the level that I'm speaking at. So we had to move this up 4 notches to give it a little bit more power. That doesn't sound like a lot, but trust me, those add up, especially when you start to move into more microphones that may require more power. So just like there is easy to drive dynamics, just know that there is easy to drive broadcast dynamics. And you're going to be able to see that as we switch over to the Shure SM7B in a moment. So as you can see over here, you can see the levels, and you can also see the preamp. I did not change it. That's the reason why I had this preemptively switched. We are talking into the Shure SM7B at the same distance, at the same volume, but as you can see, we are really quiet now. What just happened? Well, it wasn't an amplifier change, it was just a microphone change. These are the intricacies, the context-based gain requirements of microphones. This is the concept I want to drive home. And I know it took a long time, 10 minutes of the video to talk about this, but you have to understand this. It's not that handheld dynamics are worse than broadcasting dynamics, it's just that each kind of dynamic is made for a specific use case. So, not only is their frequency response going to be talking about that, again, that's going to be the frequencies of sound that it can capture, or its size, but it's also going to be the gain requirements. So since this is a beefy radio broadcasting microphone, that's also a dynamic. We're going to actually go back here and we're going to increase the gain knob a little bit. We're going to try to make sure that we're getting at that healthy level that we really require, especially for my voice. And it looks like right there, we have to go all the way past 3 o'clock. And now we're finally getting a very good level for the distance and the volume that I'm speaking at. So there it is, Shure SM7B at a proper level that is, for me, I deem necessarily good for a recording. Amazing. So what have you learned from this so far? There's different kinds of gain requirements for even broadcasting microphones. But besides dynamic broadcasting microphones requiring more power, you also do have handheld dynamic microphones that can actually require the same amount of power or even more. So cool. Even within their subcategories, there's some that are more hungry than others. And just know this because it's important for this next part. For the next 8 minutes, I don't know how long this is going to take, but I'm going to try my best to be as quick as possible. We're going to be talking about the 3 levels of noise. So as you can hear in the recording right now, there's that hiss noise. That can be a number of things. There's going to be noise of the room. There's going to be self-noise from the microphone, and there's also going to be self-noise from the amplifier, which in our case at the station is going to be the mixing board or the control board. So, what are these 3 levels of noise? Well, let's start off simply here. Noise in a room can come from multiple sources. It can come from your phone. It can come from the other electronics in the room. It can come from fans from a computer. It can come from the AC or the heating vents in your home. Believe it or not, your microphone's going to be able to pick that up. So, interesting. Awesome. There's room noise. And there's also other ambient room noise that can happen, such as rubbing your shirt, dropping your headphone cable on your desk. It could even be typing. There's other sources of noise that, of course, we don't want the microphone to capture. That's why we labeled it as noise. But there's also self-noise. Self-noise, what the hell is that? Well, there's self-noise of the microphone, because when you pump voltage or power into a microphone, you are also going to be activating those electronic little switches and capacitors and all that kind of jazz that magic go, and it makes a microphone work. And because of that, depending on how expensive the microphone is, there's going to be technology that's not only put into how a microphone sounds, but also into how it handles its own noise that it develops when you pump power through it. So, some microphones are going to be more noisier when you put power through them than others. And not only that, the amplifier itself can have its own noise. If you unplug everything from the control board or everything from your interface, pump the gain knobs all the way up. Be sure not to have anything plugged in. But you're going to hear, as when you put the faders up or you put the gain knobs all the way up, there might be a hiss that appears. That is also the noise that is self-made from your amplifier, your interface, or whatever you're plugging an instrument or a microphone into. So that's very interesting. We have 3 layers of noise. We have noise from the room, noise from the mic, and noise from the amplifier itself. So how do we deal with this? And can you even hear it? I'm going to boost the noise by a few decibels so that you can kind of attentively hear what it is that I'm describing. So you can kind of hear me breathing there a little bit. I tried to minimize that as much as possible. But all that hiss can be a number of things, but it's going to be truly, typically, one of those 3 levels of noise. The room, the mic, or the amp. We can take care of a few of these things. We can get a better microphone that has lower self-noise, or we can treat our room acoustically, or make our room isolated. But there might still be noise, and that's going to be on the amp level. No matter how much money you spend into an amplifier, there's going to be a chance that those microphone amps, typically they're called microphone preamps, they're going to be noisy, no matter how much money you spend. So, how do we deal with this? How do we minimize the amount of noise? Simple. Using microphone technique and lowering the gain. If we come closer to the microphone, it means we're going to be louder. Yeah. Okay, that's something that we learned on the basic videos for Up to Spec. Now, as I come close to the microphone here, I'm not going to change my distance. I'm not going to change how I talk. I'm going to be talking still at the same volume. But what we're going to do is we're going to switch over to the gain knob, and we're going to actually compensate with distance, not with how loud I'm speaking. And we're going to now be capable of lowering the gain. So you're going to see right here, I'm going to reach over for my gain knob, and I'm going to bring this down so that way at this distance, I'm going to be talking at this loudness or whatever, and I should be still hitting our target. And right there, just 2 notches, but it looks like I might have to get away with going a little bit above 3 o'clock, and it looks like maybe 1 notch more, and that might be a good spot. So right there, at around 3 o'clock, at this distance and at this loudness, I'm going to be hitting what I would consider very necessary levels, and it'll be adequate for recordings. And all I did was not change how loud I'm talking, but I just came closer to the microphone. Amazing. And you're going to hear that the noise in my room is not as loud as my voice. And that means that with the power of plugins, we can actually remove a little bit of that noise more. Now, I can't do that live, but I can throw the equivalent of gates, or what are those called? Expanders. I can throw those on using hardware, which I do have accessible to me right now. So I'm going to turn off the bypass feature on my compressor or my processing unit, and you're going to hear that the noise will be removed. And now this is the same equivalent of using some kind of plugin for noise removal. And there it is. I'm at a proper level. It looks like I'm actually peaking a little bit more, so I could maybe get away with removing a little bit of that gain right here. So right around here, maybe a little bit more. There it is. Yeah, right there. Yeah, I'd be happy with that. So we removed even more from the gain. And man, there's going to be, I'm not going to lie, there's going to be not a lot of noise like when I had to talk at a fist away or so. And again, the only reason why we teach to speak a fist away is actually to deal with minimizing the amount of plosives and wind that are caught in a microphone during the recording. But if you have really, really good plosive protection, or some kind of protection to help with wind noise and plosives, you can come as close as you want to the microphone and you can speak as loud as you want into the microphone, but you just need to lower the gain. And in doing so, not only will you sound pretty good, but you're also going to have a really low noise floor that will not be caught in the recordings. So, hopefully this video was useful. It is going to be almost 20 minutes and I'm super sorry. I can't stop apologizing. But man, this is two concepts that again definitely deserve their own video, but they just work hand in hand and I love sound, if you can't tell. And these are important if you start to just delve a little bit more deeper into gain and how do I get a good sound? How do I sound the way I want to on a microphone without having to worry about all this stuff? Well, gain, distance, and knowing your microphone. So, thanks so much for watching this video. Hopefully it was useful for you, not only at CGSW, but also if you decide to buy your own kind of microphone and you're doing your homework, giving a little listen, maybe auditioning the microphones at places like Long and McQuaid, and it will help you make a very informed choice, especially during these times of COVID. If you're deciding to start up your own home studio or have some means of recording at home for CGSW related inquiries. So, goodbye. I'll see you guys in the next episode.